Hey everyone, I'm back in Cologne, and as you can tell it's really quiet, and partly that's because it's so early in the morning, but partly also because it's Ascension Day, which is a public holiday in Germany. So what do you do with an astronaut on a public holiday shortly before his mission? Well, you send him to another country where Ascension Day is not a public holiday. No, I'm just kidding, but only a little bit. So I'm on my way to France, to St Etienne, where they have a special scanner where I'll have my leg bone scanned as part of some of the research that we're doing in connection with my mission. The purpose, of course, is to understand how the bone density changes even under a short duration flight. So I'll fly there just for the day, have my bone scanned, and then back to Cologne this evening, and ready to work again tomorrow when it's not a public holiday. Turns out I just discovered that Ascension Day is also a public holiday here in France, but Laurence and her team of specialists are going to run tests on me regardless. Just goes to show that science never stops. So I'm at Hôpital Noir in St Etienne with Laurence, one of the principal investigators of the EDOS experiment. We're standing in front of a high precision computed tomography machine that we'll use to study my bone density before and after the mission. Perhaps you'll tell us a little bit about the science behind it?
The science behind it, so we know that in space we don't use our musculoskeletal system mainly on the weight-bearing part of the skeleton. So there will be an adaptation to microgravity, and we will lose bone. We don't know exactly at what speed, the kinetics, and when we will reach a steady state. So we need this kind of machine to really look with precision what happened on not only on the bone density but also on the bone structure.
So even for a short 10-day mission, it's interesting to see when some of these effects might start.
Yes, exactly. Just to have more data on these kinetics, it is possible, based on the bed rest results we already get, that it is possible that some very slight or tendencies are already on process, because we know that the bone cellular activities will be challenged. Even after 10 days, we are really expecting an increase in the bone resorption, and this is something we will also evaluate on your blood. That's why we collect the serum to analyze the bone markers, systemic bone markers in the blood.
And obviously this has benefits for astronauts in space, but also for people on ground?
Also for people on ground, and I can tell that this machine has been built because of space questioning, but now it is used in all over the world in research center to study bone fragility in osteoporosis or in other situations.
All right, very interesting. And what you're looking at here, the results, is a scan like this?
Yes, so this is a scan. Maybe Hervé can come to comment better than me. So here it's a section, so you have the leg with the muscles, you can see very well, and this is the tibia and the fibula. So you can see the cortical bone, very dense, and inside you can see this network of trabeculae. They are all connected, they look very nice. They are all connected each others, and we will see when you will come back from space if we have some differences in, for example, the thickness of the cortical bone and also the connectivity in the trabecular bone. If you have less trabecular number, if the trabeculae are thinner also, we will be able to quantify all these parameters.
Well, that sounds interesting. I look forward to coming back after the flight for another scan, and we'll compare the results.
Yeah, okay.
Excellent.